Hi. So the problem we're going to do today is switching from grams to moles. It's a fundamental skill that you'll need to have in chemistry. And basically, it's because this allows us to relate um, the reactants in a chemical reaction to the products. And so things that have different masses um, will relate to each other on the level of moles. And then once we know how they relate to one another using moles, we can actually measure that in the laboratory using scales that measure in grams. They can't make a scale that measures in moles. That would be because you'd need a different scale for every element in every compound, and obviously that would be inefficient. And so we need to instead learn how to convert from grams, which we can easily measure, to moles. Okay. So we'll start out really simple, and I'll do a couple videos on this just since it is so fundamental. So if we start out with 12.15 grams of magnesium, and I don't know why I keep writing uphill, but maybe by the time we get to the 10th or 12th video, I'll start writing downhill or something. So this is given, and this has 4 sig figs in it, and so I'll talk about sig figs when we actually get our answer. But the problem asked me to take those grams of magnesium and switch it to moles of magnesium. And, we could also switch it to atoms using Avogadro's number, but really that's not something that we do much in the laboratory, and doesn't have a lot of application in real life. So most of the time I'm going to have you go from moles to grams and grams to moles because that's something I'm going to be asking you to do in the class, in the lab itself. So the first thing I'm going to do is I'm going to write down the relationship, and I will do all 3 parts. So 1 mole of magnesium is equal to 24.31 grams of magnesium. Now, I got that from the periodic table, and so the average atomic mass of all the magnesium isotopes in the world is the average mass of each isotope in AMU is 24.31 AMU. But when you put it on the level of moles, that's 24.31 grams, which we can measure easily in the lab, and you see why a mole has a great utility. So 6.02 times 10 to the 23rd, and since this is an element, it's going to be atoms. If you're an element, use atoms for Avogadro's number. If you are a ionic compound, you use formula units, which FU. I know I could make a bad joke about that, but we'll do that in class sometime. And then if you're a covalent compound like water or carbon dioxide, that's actually a molecule. And sometimes people just put molecules for the ionic compounds too, but really more correctly they are supposed to be formula units. So I have this relationship now, and 1 mole of magnesium is 24.3 grams of magnesium, and then it's this many atoms. But all I'm being asked to do is grams of magnesium to moles, okay? And so I take my 12.15 grams of magnesium, and when you set up this problem, always be sure number, unit, and kind. So my number is 12.15, my unit is grams, and then my kind is magnesium. And then make sure that when you set up your ratio like this, the top is what you want and the bottom is what you have. So I'm going to be putting grams on the bottom of the ratio to cross it off. And so 24.31 grams of magnesium there on the bottom. And then I want moles. And it does say, I was like, it doesn't say it, but it does say. And so I know that in 24.31 grams of magnesium, I've got 1 mole of magnesium. So that is a true statement. And whenever you have this ratio here, it has to be a true statement. 1 mole is 24.31. And that will keep you from trying to put this number in a ratio, because this is nothing special to magnesium. It's just the number they gave us. Okay, and so I just multiply across the top, which is easy, and then divide by the bottom. So 12.15 divided by 24.31, and that's going to be, man, they always do this. Okay, 0.4997 9, and then 4, 3, 2, 3. And, you know, that looks messy, this, and that will be moles of magnesium, okay? And so what you do is you realize here that you have 1, 2, 3, 4 sig figs, because all non-zero digits are significant. So you have 4 sig figs here, and since this is a multiplication or division problem, you just keep however many that you have. So if you start out with 4 sig figs, we report 4 sig figs. And so if I take it out to 4, it would be like that. And then that 9 here rounds up to 7, and so the proper answer would be 0.4998 moles of magnesium. And if you had been asked in the lab to get 12.15 grams of magnesium, and you know, to get half a mole, and you ended up with this much, you'd be doing pretty good. So just remember that your ratio always has to be a true statement. Okay, thanks a lot. Bye.